going to talk about adding probabilities. Before we can do that, we need to talk about the union and intersection of two or more sets. Okay? A union, if you have two sets, A and B, the union of those sets is essentially taking everything that is in both and combining it into one big one. Okay? We can represent union two ways. We can represent it with an upside down U, or sorry, a normal U, or the word or. Whenever you see or that U-shaped symbol, that means you're doing a union, meaning you're taking the two sets and combining it as one set. Okay? If you have any values that repeat, so if they both have a 2 in their set, you only have to write that 2 one time. So if you have any repeating values, you don't have to write it again. You only need to write it once. The intersection of two sets is taking what the two sets share and writing it as one set. Intersection can be written two ways. It can be written with the word and or an upside down U. When you see the word and or the upside down U, that means their intersection. You're just writing down what they share in one set. Okay? I'm thinking in terms of a Venn diagram, union is all what's in the side circle. Okay? That would be a union. Okay? You only write what they share one time. So if they're sharing something, you only have to write it once. Okay? You don't want to repeat. The intersection is the middle part of that Venn diagram. It's what they're both sharing. Okay? And union, what's in both. Intersection is just what they're sharing. Any questions over that? If you see the word or U, you're doing a union. If you see the word and or an upside down U, you're doing intersection. The upside down U kind of looks like an N, and there's N in the word and, so one way to remember it. So we look at this first example. Set A has all those values. Set B has all those other values. We want to find their union and their intersection. When we look at the first one, the symbol is a U. So which one does that represent? Union. The U represents union. So what I like to do, again, that's taking what's in both sets and combining them as one big set, but not writing the repeating values. So I just like to write the first set. 1, 7, 9, 11, 12, 17, 23, 45. Write everything that's in the first set down. Then what you're going to do is look at that second set and write the numbers that aren't already there. So did we already write a 3? No, so we're going to write it. Did we already write a 7? Yep, we're not going to write it again. Did we already write a 12? Yep, we're not going to write it again. Did we write a 13? Nope. I'll write it down. Did we already write a 17? Yep, no, don't write it again. Did we already write a 23? Yep, we don't write it again. Did we already write a 45? Yep, don't write it again. Did we write a 56? Nope, don't write it again. Those are the total records. And the union is what's in both sets. If they repeat, you only have to write it one time. So in this one we have the upside down U, so that's representing intersection. Okay? So what both sets share. That's hard to say. So look at both sets. What are they sharing? What do they both have? Both have a 7? What else do they both have? They both have a 12. What else do they both have? They both have 17. What else do they both have? 23. And then what else do they both have? 25. They both don't have 56, they don't write. You might have seen this one as A or B. Same exact steps if you have A and B. Same exact steps. Okay? It's just this U shape just literally means or in math if you like interpret math. Translate math. U means or in English. Upside down U means and in English. One way to think about it. Questions? Right. We can use these now that we know about unions and intersections. We can now go to the addition rule. Okay? When you're trying to find a probability of A or B, of one event or the other event happening, you have to follow this formula. Okay? It's your responsibility to know this formula. They're not going to give it to you on your OST, so we're not going to give it to you. That way you can prepare for it and have it memorized in your head. Okay? Whenever you see the word or and you're finding the probability, your instinct should be to write down that formula. Okay? So if you're finding the probability of A or B, to find it, you do the probability of the first thing plus the probability of the second thing minus the probability of both things. Okay? The reason why we have to subtract both, the and, because they share things. Sometimes in this set A had same things that were in set B, and if we were just to add those two sets together, again, you have repeating values. Okay? So to get rid of those repeating values, to get an accurate probability, you have to subtract their intersection, because the intersection is what's containing those repeating ones. Okay? So, again, just follow the formula and you'll be fine. Whenever you see the word or, write it down, plug in the appropriate probabilities. Okay? And you, on your tests, quizzes, things like that, you have to know that. You have to recognize, oh, it has or, I need to write that down. Okay? And then plug in the values. So look at this first example. We are given the probability of A, we're given the probability of B, and we're given the probability of both. We're trying to find the probability of A or B. So what should we write down? You see the word or? What do we write down? Yeah, write down the formula. Whenever you see this, automatically, probability of the first, what's the probability of the second, minus the probability of both. Every time you see that word, write down the formula. Now, what's inside your parentheses will change based off the scenario. Write it down. Then plug in those values. What is the probability of A? What's the probability of B? And then what's the probability of both? Written right there. In the direction. 2018. Plug in your calculator. 0.64 plus 0.32 minus 0.18. What do we get? Example 3 is really similar. Given these probabilities, we want to find the probability of A or B. So again, you see the word or, triggers in your brain, write down the formula. Probability of the first plus the probability of the second minus the probability of both. Every time you see that word or. Again, what changes inside based off your scenario will change, but same kind of thing. Probability of the first plus the probability of the second minus the probability of both. Alright, well, what's the probability of A? What's the probability of B? Minus what's the probability of both? Go ahead and subtract. questions over there?
Some of you guys are sitting there saying, man, I don't know what's going on. Well, you do. We'll show you. We'll do an example that's very similar to what you just took a quiz over, and you'll be able to solve this. So we have this a two-way frequency, meaning that we're kind of analyzing two things at once. So here's an example how sets can combine, a union, and how they overlap the intersection. Let's take a look at this in the next example. So example 3, a small high school surveyed 52 of its seniors. Very small high school if it has 52 seniors. About their plans after they graduate. They found the following data and wanted to analyze it based on gender. In this case, we picked a student at random. We can place them into one of 4 categories. M, male, F, female, C, going to college, and not going to college. So there's the chart up there. You see everything else we got, but look how it lies and how it's set up. Well, how many kids did we analyze? How many seniors were there? 52. It says total, 52. We can see the breakdown, whether they're male or they're female, going to college or not. Well, let's find the probability, just like you guys did a little bit ago. So, probability of M, look at my chart, of male. Well, how many males are in this school? How many senior males are there? How many? 30. I look, here's males. Go down to the bottom. There's 30 of them. So I have 30 males. Out of how many? 52. That's the total. So it's out of 52. What do we need to do with our fractions? Let's simplify fractions. Always, always. Don't give me decimal yet. Just please simplify the fraction. So 30 over 52 gives me this number, and everyone should be reducing. Everyone's fingers should be touching a calculator. And you get this number. And this number is 15 over 26. You divide both by 2. Great. That is the fraction of it. We want to know its decimal. So what is the probability that I would, at random, pick a male out of this group? 0.58. Make sure you guys are doing good rounding situations here. All right, well, great. That's the probability of getting a male at random. What about the probability of female? And I'm sure some of you can figure that out just by looking at it. But let's set it up exactly the same. How many females are in the school for the senior class? 22. Still out of the total of that 52. And we need to reduce our fractions. So when I do that, what do I get? Yes. What would you say? 11 over 26. Great, works out. So what is that probability going to be? What's going to be my decimal of this? Lauren? 0.42. Huh. What do you notice about these two numbers? They add to 1, which they should have. Because if I have a school of males and females together, that's got to be the whole population. That makes sense. Well, what about this next probability? Probability of C. C represents going to college. How many students are going to be going to college? 29. Here's going to college. I'm zooming over. It's 29. So there are 29, and still, there's still 52 kids we're surveying going to college. What's that reduced fraction? What's 29 over 52 reduced down to? Huh? It doesn't reduce down to the fraction, right? But when you get a decimal, what did you say you got? 0.56. 29 is a prime number, guys. It's not going to break down any further than that. So 0.56. So a little over half the population is going on to college of the senior class. What about this next one? What about the probability of not going to college? Really, it's a complement of this. Well, how many are not going to college? 23. Still out of the total. And 23 over 52, still find out? Lauren says no, shaking her head. So Lauren, what's the probability though? 0.44. And just like the situation with the genders, together those scores, the probability of those better add to 1. Because I'm doing You're either going to college or you're not going to college. Those are two options. You can't not vote in this poll. So everyone's going to college or not college. There you go. After one. Well, now we have this and situation. What's that mean? Well, before you had the percentages already done for you. Well, here, basically, is what it's saying. What is the probability of picking a male that's going to college? He's a male and he's going to college. So what's the probability of being a male going to college? Jason?
You would do, you would just use the number 16 and divide the total instead of...
Yeah. You're saying there's 16 males going to college. You're exactly right. So I'm going to do 16 over, well, I'm still pulling from the whole population, so it's still 52. Reduce that fraction. What's 16 over 52 reduced down to? 4/13. So 4 out of 13 times, I'm going to grab a male that's going to college. Hold it. Now, what's the probability of this? What's 4 out of 13? Divide it. Do 4 divided by 13. You'll get a number. That number is a decimal. 0.31. So really, if I move that decimal over twice, I have a 31% chance of picking a male going to college. Not bad. I'll play the lot with those numbers. Well, what about the other way? What about the females going to college? The more males go to college, more females. Well, there's more males in this poll that I'm doing, so we'll see what the percentage is. So what is the probability that it's a female going to college? How many females are going to college? 13. Going to college, females, 13. So I have 13 out of still 52. What's 13 out of 52 reduced down to? 1/4. Now, we know what 1/4 is as a decimal. Think about a dollar, you got a fourth of it. It is quarter, 25. Quarter. So 25%. So you have a better chance, again, if I'm playing the lotto, if I'm playing roulette at the casino, what would I rather bet on? Female going to college, male going to college, higher odds are over here. I go with this. And again, these change from things to things, but you can figure out the probability of this one now. Now, what's different about that next one? It's different than these two. Why? So whenever you see or, what do you need to do? Well, we're going to write down the formula. There's subtraction involved in that. So we're going to find the probability of the first one. So here's what I'm writing down. Anytime I see that or, the probability of the first event, probability of it being female, plus the probability of it going to college, minus the probability of F and C. That's hard to write. Well, we have all the data. Let's plug it in. What's the probability of it being a female? 0.42. Is that right there? What's the probability of that going to college? Decided. Plus 0.56. What's the probability that a female is going to college? And I'm going to subtract that off. Minus 0.65. And when I do so, I will get the probability that whether it's a female or going to college. And that number is, so 0.42 plus 0.56 minus 0.25, 0.73. Move that decimal over twice, you got a 73% chance of picking a female or someone going to college.
Yeah, 27. You took on top.
This is around?
No, I got
7, 6.
I get 73.
Yeah, it should be about 0.73. Yep.
Exactly.
42, 0.56.
Oh, 0.56.
There you go, that might be your issue. That's it. Like those odds. Make those all day long. Question with that? Alright. Another example.
If we look at example 4, so the standard 6-sided die is rolled once. Find the probability that the number rolled was either an even or a multiple of 3. So sometimes or is kind of hidden in the word problem. So if you're given a word problem trying to find the probability of this or that, you're still writing down that formula. Okay? Probability of the first thing. What's the first thing we're trying to find the probability of? Find the probability of an even. Good. Plus, what's the second thing? Multiple of 3. Just abbreviate. I put like times 3, something along those lines. Minus probability of both. And times 3. Well, here's the thing. We don't have a table or anything to get these probabilities, so we have to find them. So we know probabilities we first write as a fraction, so I know there's something that looks along the lines of this. And then always, always, always write your sample space. Okay? So Jason, do you have a question?
No, I was gonna ask him to use the restroom.
Go quickly. So again, write your sample space. So if you're rolling a 6-sided die, what are all the possible outcomes? Yeah, 1 through 6. 1, 2, 3, 4, 5, 6. Good. I always just like to write my sample space so I know what I'm dealing with. Well, how many total possible outcomes are there for rolling a 6-sided die? 6. There's 6 items in our sample space. So we know our total is going to be 6. So we know 6 is going to go in the bottom. We just have to figure out what's going to go on the top of each fraction. So the first probability is even. Go to your sample space. How many of these numbers are even? 3. 2 is an even number, 4 is an even number, and 6 is an even number. So of those, 3 are even. Go back to your sample space. How many of them are multiples of 3? How many? 2. 3 is a multiple of 3. And 6 is also a multiple of 3. So there's 2 of them. Of those, how many are both even and a multiple of 3? How many are even and a multiple of 4? 1. 6 is an even number, and it's also a multiple of 3. You notice you put 2 arrows, you put a purple arrow and a blue arrow on 6. So 6 is the only one that fits into both. So there's 1. Well, when we combine fractions, it's really nice. We know the bottom is going to stay the same, so really all you have to do is combine the top. That's 3 plus 2 minus 1. And that simplifies down to 2/3. And then what is that as a decimal about what? 0.67. So sometimes you have to figure out the probabilities. So write down your sample space. Get the total number of outcomes. That's going to go on the bottom. Look back at your sample space to figure out how many fit in each event. And then going in on the top. Simplify it down. Questions?
All right. That was some real world examples. Where could I use this in my life? Well, if you're lucky, we'll show you. All right. You guys have insurance? Hopefully you do. If not, sorry. Even if you're driving a car, you have to have insurance. It's illegal in the state of Ohio not to have insurance. If that's the case, you're driving illegally. Huh? That's a good question. I don't know other states. I'm sure it is, but I don't know for sure. But we got an insurance company. So we have an insurance company typically tries to sell different policies to the same customers. At one such company, 56% of all customers have car insurance policies, 48% have home insurance policies, and 18% have both. The customers picked at random. Find the probability that the customer has at least one of these policies. So when you see the word at least one of these policies, it's really saying or. Which one has one or the other? It's got one or the other. We're going to both, but we're going at least one of these. So we have an or. What do we need to do when we see or? Write down the equation. So we know it's the probability of one plus the probability of the other plus the probability of them together. Well, let's talk turkey here. The first probability is what kind of insurance? Car. I did there? My name has two R's, so I put it in there. Probability me. Car. Plus the probability of the other one. What's the other type of insurance? Home. I can't do anything with that one. Minus the probability of both. So let's do probability of both. Car and home. Alright. Well, if you notice, these are actually percentages. We don't really want to work with percentages. What do we like to work with in these problems? How do I turn this into a decimal? Move the decimal over two places or divide by 100, however floats your boat. So I'm going to do the first one of car. I'm going to do the car insurance. The probability is 0.56. What's the probability of home? Great. Minus the probability of both. 18% turns into 0.18. All right. Well, what is this decimal probability going to be? What is 0.56 plus 0.48, 0.18? You get, you do 48 minus 18 plus that is 0.86. 0.86. That doesn't really make sense. All of our answers were measured in percent. So what do I have to do with this? Let's turn it back into a percent. So of the customers of this, how many of them have both one or the other policies? Well, you get about 86% of them. Pretty good odds. So it's going to be 14 of them. 86% have both. One or the other. Questions on that? Cool. Glad you guys are doing this. What do you say?